Hello, my name is Rich Howard, owner of Architectural Builder Supply, and the project that I'm working on now is making the wood underliner that you're gonna see when you go to the Mexican restaurant and you order fajitas, and that cast iron griddle comes out so hot that it's impossible to touch that. But there's always a piece of wood the griddle sits on. So what we're making actually is 50 of those underliners. And the reason that I'm making them is because the manufacturer has discontinued them, and it's not impossible to find underliners in the world. But from what I was told by the manufacturer who discontinued them, is they went from decent quality material all the way to extreme low end, very low quality items. And it's either refund the client the money, discontinue all the underliners, or simply make them and then adjust moving forward. So we've got the machine, we have access to tooling, we've got the CAD CAM software, and we've got Moxie, and it's the Moxie that we're going to record today, hopefully. So let's show you what these underliners look like. Here's what the underliner looks like. This is it. Comes in this piece of plastic. And I never paid any attention to these. We sell food service items, cup dispensers. The gaskets for cup dispensers, when you're in the convenience store and you pull out a big styrofoam or plastic cup, there's a rubber gasket there that holds all those cups inside of there. There's a big spring, there's a pusher, there's all that stuff. We actually sell that material, and while it's not builder's hardware, it's not unrelated. And that's food service equipment. This underliner is food service equipment. Well, admittedly, I never paid much attention to it. When this order came in and it was discovered, yeah, it's discontinued, we have 4 still in stock. And I said to one of the workers, I said, pull one of those out and let me take a look at it. Well, they brought this to me, and I was, quite frankly, I don't expect to reinvent the wheel or to change anyone's life with what we're going to make, but I was extremely underwhelmed with the quality of what was happening here. Extremely underwhelmed. And I thought, well, gosh, let's study this. So let's actually study this. It's a piece of plywood. That's number one. It's evidenced the fact that you can see the different layers of the plywood. I mean, I would want to call it Luan, even though it's probably Honduran mahogany. So it's an open grain wood that's been stained walnut. And it obviously has the physical dimension of the width and the height and the depth, and then the thickness. And then it's got, what does it have? So when I first saw this, what I thought to myself is there looks to be about 4 different tool paths on here. And I've been thinking about it a little bit, but there seems to be a pocket profile here, right? So we're going to pocket this. Then there appears to be a ball groove here. So I'm thinking we've got a pocket, and then I'm thinking that we've got a ball groove in this pattern, and then we're done. On the other side, what do we have? We obviously have a V-bit. Who cares what angle it is? I mean, not who cares, but, match that. And then you obviously have a bit that's just doing a profile cut. And I thought, well, gosh, that can't be awful. What'll be the least fun part about all of this will be white coating some sort of, walnut stain on this. That'll be the part where we'll actually have to do labor. The machine's going to do all the work. So I think that's correct. And my approach to cutting this material, and please tell me if you disagree, but right now, what I'm thinking about is using tabs for sure. So what I'm thinking about is a 2-sided file in VCarve Pro. I'm thinking about doing a big giant pocket here. I'm going to use a upcut bit for doing this pocket. I'm going to use an upcut ball bit for doing this perimeter. Yeah, definitely a ball bit. Definitely a ball bit, not a V bit. Then I'm going to flip the sheet over. I'm going to do a V bit around the perimeter, here over. Then I'll do an upcut end mill, probably 3/8 all the way around. Tab, tab, or tab, 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 whatever will take. It's going to take. And then I'm thinking at that point, it's break the tabs, take the pieces and hit it on the sander. Great. Give everything a quick sand. No big deal. And then lay them all out and get a good coat of stain on it. Let that set. Flip it all over. Get a good coat of stain on it. Maybe do a small amount of sanding. These were certainly sprayed. I'm not going to spray. I don't have a spray booth. It'll be done by hand. At least it will be now, initially. But there's not a lot of TLC on this stuff. And quite frankly, it's not like a cornice or it's not like a plinth block or it's not a mantle. This is something that just needs to be durable, is what it is. A sealed piece of plywood would certainly be durable. So 1, 2, 3, 4 different bits, and that's it. I think that's all it's going to be. So I'm going to show you what bits I plan on using. Then we're going to take some dimensions, and then we're going to switch to the screen view, and we're going to start drawing this in V-carve. So let's show you the bits next. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, so let's take a look at tooling. So let's start with what I had said first. The pocket. Obviously, it would be smartest to use the biggest bit possible. I could use my bit that I use to surface my spoil board, but I literally want to use a 60-173 MC. This is a compression bit. This is not the best bit for doing this. I just happen to have dozens of these brand new, several dozen, to the point where to Chris Burns from ShopBot, I donated 12 of them because he does charity work for low-income neighborhoods and schools, teaching the students in high schools how to do CNC work. And I buy these on eBay, and they must have fallen off a truck because this is like a $60, $70, $90 bit, and they must be falling off a truck. It's a compression bit, meaning that it's got a down spiral feature here, and it's got an up spiral here. So obviously I'm going to use the pocketing for the up spiral. And I'm going to use this because I have dozens of these, and it's really not the right bit to really use for everything. It's 1/2 inch diameter, and I don't like to put so much energy through the workpiece by using bigger bits. I'll use thinner bits based on my experience. I could be completely wrong. But the bottom line is for the pocketing, what I'm going to do first is use a 60-173 MC by Ansrud. Now, here's the big dog. What am I going to use for the ball? Well, it's not a V-bit. It's a ball. And I kind of measured it by eye. It's the first ball bit that I've ever owned. This is an Ansrud 50-397B. There should be an up spiral. Yeah, this is an upcut. Definitely an upcut. We're going to do a study sometime on the difference between upcut and down cut or up spiral and down spiral to look at finish quality. There it is, a big solid carbide giant bit. Now, I don't know if this is the right size, but I believe it to be based on all my dimensions. And when I literally place it on here, and I haven't until now, unscripted drama, yeah, it looks like it's really, really, really good, really accurate. I'm happy with that. So a big giant, this bit was not the least expensive bit I've ever bought. So we're going to put that back. And that will give me what's going to be the top side, which I'm going to machine first. At least that's my plan. I got to machine this first. I have to. I think you'll agree. I've got a pocket. I've got a ball bit. I've got to flip it over, do the V bit around, and then do the profile cut and leave the tabs. I don't see any other way to do this. But that statement is based on my relative limited experience. So now the underside, what are we going to do next? Well, the way I want to do it is I'm going to put that V-bit, and Amana is where I generally end up going to when it comes to V-bits. I don't necessarily use Amana like as my first choice. I've used a lot of Amana bits. I've really had no problem. The only issue may be the fact that your speeds and feeds, all of that stuff has to be well thought out. I really like Ansrud, their layout of speeds and feeds. It's less obvious to me what Amana is doing with speeds and feeds. There is a max RPM that this is going to be designed for, and we're going to have to study that. When we build these in the tool database, we're going to really be studying the speeds and feeds. So we're going to come with a V-bit, and that's just spot on. This is a 90 degree. 90 degree? Yeah, this is 90 degree. The degree is measured from one side to the other side, from here to here. Okay, so 90 degree. When I hold that up on here, I'm liking that. I'm liking that a whole lot. Okay, it's a big bit. I have other 90-degree bits. They're smaller in the sense of their height. And the problem with those other bits is I would have a ledge here because the bit is not tall enough. So I do have this bit. I don't remember what I bought this for. I did buy a V bit for this job. It's just too small, so I'm using this one, which I have in my arsenal. Then the last bit, and I could certainly use the 6173 MC for the perimeter, but I'm going to use a 3/8 bit. I like a smaller amount of energy being pushed into the workpiece, meaning fixturing it. I'll have the vacuum clamp. I'm probably just going to use hand clamps to hold the workpiece down because I'm not going to be very aggressive with how fast and deep I'm pushing the tooling. I don't care if it takes 2.5 hours to do a cut or 3 1/4. I really don't care in the sense of the first time out. The proper way to do this, according to Ansrud, it's in their catalog, is optimized. So if this 50 that I'm making turns out to be 5,000, we are going to get deeply into optimizing. I'm going to see how fast I can push the work for time. How quickly can I move it and not degrade tool life, quality of cut, finished product, that kind of stuff. The last bit I'm going to use for the perimeter, the profile, is a 5120 by Ansrud. It's a 3/8 down spiral. No, yeah, obviously it's a down cut. That's not what I want to use. I want to use an upcut because I want the quality of the finish here to be better. So let's pause this and see if I can find an upcut bit. Okay, I have a 6123 MW Android. It's a compression bit, but it's 3/8. So it's like my 6173, except that it's smaller. And that upcut profile will be what I want because the upcut spiral will give you a cleaner finish on the bottom, and a down spiral will give you a cleaner finish on this edge. So I'm using an upcut for the pocket. I'm using my 6173. That's a compression bit. So it'll give me an upcut here. My ball bit is upcut. I want a clean cut in here, obviously. My V bit is just a V bit. There are no upcut or downcut on those that I've ever seen. And I want an upcut here, so I'm going to use that 6123 MW. That's a nice bit to have. Solid carbide, 6123 MW, double-sided, laminated and veneered wood composites. Perfect. It's a compression bit. So compression bit means it's partially down spiral, partially up spiral. So that's going to be my deployment of choice on all of this. Okay, so now the next thing is to take measurements of this and see what it all looks like. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Now, some dimensions. Let's take a look. Overall length is 20 3/8. Okay, 20 3/8. Overall width, 9 7/16. Great. The depth of that pocket, if I'm eyeballing, it's about 3/8. The overall thickness of this plywood is 5/8. We're going to be using 3/4. I'm going to show that to you. So at least get slightly more technical with this. What I'm trying to figure out is if this has a consistent radius. So I'm going to put my pencil mark at 4 inch, and I can tell by the machining marks where this is awful, this job. Yeah, it appears to be has a 4 inch radius. So that's good because obviously I want the griddle to fit into this, which means if the overall height of the cut of the pocket is 17 1/4, this should be at 9 1/4 on its flat end. And it appears to be pretty realistic. So what we can certainly do with the machine is cut us some circles with an 8-inch diameter and see if that fits in there really well. Yeah, it does appear to look good, meaning I can detect with my eyes where the machining changes from straight to this radius. And I would have to think that there's nothing hyper unusual about this and that they're just using pretty typical sizes. When I measure the rest of this, 3 11/16, 13, yeah, it's consistent. It's consistent. Yeah. Okay, I don't see any trouble with any of this. So what we're going to do now is we're going to switch to the screen view, and we are going to get VCarve Pro up, and we're going to start to detail this. And I'll double check this as we go through along the way to make sure everything looks correct. Here goes nothing. It'll be a double-sided workpiece. We've talked about what our tools are going to be. It's the first time we're ever doing it, so continue on with the Moxie. That's what we're doing. This is what we're making. We're making the wood underliner. I don't have one of these griddles to place in here, but I have no reason to believe that this is an ellipse, but I don't know. So this is what we're making. Underliner for Tomlinson 1016982, serving griddle with handles 6-pack. Let's look at the product catalog. That's a 1016982 right here. 1016982 OP25 griddle. 4 in a case. Cast iron serving griddle with handles. 18-inch by 9 1/4. Yeah, the overall of the wood liner is 9 1/4. Yeah, the overall doesn't match anything that we're doing here. All I know is we're duplicating this, what I have in my hand, and all I can say is, boy, I sure hope that it works. If it doesn't, the client's going to have to send us a cast iron griddle and I can make it off of this. I have no reason to believe it's not, because I'm using an actual 1016984 from the manufacturer. I'm duplicating it. I have one in my hand, so we should be okay. So let's just see what happens here. Okay, so before we start to draw this, I'm going to show you the plywood that we're going to use, because starting to draw it, I'm going to need to know the thickness of the material. I happen to have this plywood here, and I've had it for a long time because I'm doing various projects with it. It just turns out that this birch plywood I have is going to be perfect. Here it is. I've got some sheets of birch plywood here. As you can see, this sheet's got a big hole in it. We're going to use that. I got a full sheet here. I've got another full sheet here. I've done the math loosely a week or two ago. I can't get 50 out of a single sheet, but I'm for sure going to get it out of a full sheet on this partial sheet. Absolutely. So let's measure our plywood. Not super concerned about it being super accurate, because we're cutting through. This is 0.727. 0.727. Okay, go down here a little bit and see what it says. 0.728 down here. 727. Okay, let's go over and measure what we're working with. This guy, it's 0.6823. 0.683 is what this measures. So 0.683, we're going to be, 45 thousandths. 2/3 of a 1/16 of an inch thicker. That's fine. That's going to work. Put our caliper away. Button us up here. Okay, we've got our thickness written down. Let's switch and pull up the CAD/CAM software. Let's do that now. Thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.